Okay, you're going to use the definition to prove that the limit exists. This is just another example, example number 8. So I want you to set it up and then attempt to do this one on your own, then you can check your answer. So we must show that given any epsilon greater than 0, we're able to find a delta that's greater than 0 such that it's going to match these inequalities. And specifically for this one, you're going to write your inequalities. Then you want to find a proper choice of delta by examining the epsilon statement and then plug that back in to verify. So go ahead and attempt that one and then you can check your work. Okay, so these are particular inequalities for this example, and we want to be able to examine this epsilon statement and to rewrite a delta in terms of as a function of epsilon. Okay, so here's your work. If you'll check your work on that, we found delta to be less than or equal to epsilon divided by 2, and then we came up here and substituted that in, and this statement is equivalent to our one here is given. So we're done. Limit of 5 as x approaches 3. There's no variable in this function. We just know that the limit of a constant is a constant. So, but let's consider it by the definition. First of all, consider this side, our epsilon tolerance statement. Let's just plug that in. So first of all, what's our f of x in this case? Just 5. What's our limit in this case? 5. Okay, so what that's going to say is just 0 is less than epsilon. Okay, so that's true for all x. We would say that's true for all x and any epsilon greater than 0, because remember our definition specifically said we consider an epsilon greater than 0 and a delta greater than 0. So any delta greater than 0 will satisfy this definition. I will just say definition 2.4. Okay, so you can choose any delta greater than 0 and it'll satisfy that. Telling you